this series, we are going to start looking at limits, continuity, and partial derivatives. And so we have some questions here. And the first question says, calculate the limit of this function that has been given here. So number one, we have limit as x comma y approaches 1 comma 2 5x squared y over x squared plus y squared. And so for us to calculate the limit here, we are going to substitute the numbers the coordinate that we've been given here, where x is equal to 1 and y is equal to 2. And so this becomes 1 squared times 2 over 1 squared plus 2 squared. And this gives us 1 squared is 1 times 5, we have 5 times 2, we have 10. So we are going to have 10 over 1 squared is 1 plus 4, which will give us 10 over 5, and this gives us 2. Okay, so the limit as x comma y approaches 1 comma 2 is 2. So you just substitute the numbers that you have into the function. Then the next one says, number 2 says, show that the limit for this function here does not exist. So it's the limit of this function here, the limit as x comma y approaches 0 comma 0 of x squared minus y squared over x squared plus y squared, the whole component here squared. So we are going to show that this limit does not exist. Okay, so here when we look at what we are given down here, x comma y approaching 0 comma 0, we cannot get 0 comma 0 and substitute into this function, because when we substitute, we are going to find that we will have 0 in the denominator. We'll be dividing by 0, which is undefined. So the way we approach this this question is, we are going to approach the limit from two different directions. So let me draw the x and y axis here. So suppose you have the x and y axis. So this is x and this is y. Okay, so here we are told to say that x comma y is approaching 0 comma 0. So 0 comma 0 is here at the origin. So we are going to look at this function from two different directions. Number one, we'll say, okay, we are going to see what the limit is as x approaches 0, or x is equal to 0, from x is equal to 0. X is equal to 0 is just the y-axis. So from the y-axis point of view, what is the limit as the function is approaching from x is equal to 0? And then we'll also look at y is equal to x, okay, which is a line which crosses here going this way. So what is the limit as the function approaches 0 comma 0 by using this line here, where y is equal to x? So both of them we are going to see, if they give us two different limits, then it means that the limit of this function does not exist. So we'll start with this one here. The limit as x approaches 0, that is the first one, of this function here, x squared minus y squared over x squared plus y squared, the whole thing squared. So we are going to substitute 0 into this function here. So when we substitute 0, we are going to have 0 squared minus y squared over 0 squared plus y squared, the whole component squared. And so this one here is going to give us 0 squared is 0 minus y squared. This will give us negative y squared over y squared. Okay, and so here the whole thing squared there. Y squared into y squared will give us negative 1. And when you square this, you are going to have positive 1. Okay, so the limit as x approaches 0 of this function is actually equal to 1. So we are now going to solve for the limit as y approaches x. Okay, so let us look at it from that angle there. So the same function, we are going to say, okay, Let us look at it from this perspective now. As y approaches x of the same function, x squared minus y squared over x squared plus y squared here. The whole thing squared. Okay, so we are going to substitute x where there is y here. So we are going to have x squared minus, where there is y here, we'll put x squared also, over x squared plus x here squared, the whole thing squared. And so we are going to have here x squared minus x squared. On top there we have 0, and then here we are going to have 2x squared to the power 2. And so the whole component in the brackets will be 0. When we square it, it will also be 0. So we see that we found two different limits here. We found the one as x approaches 0 from this angle here. As x approaches 0, we found the one. And then from here where y is approaching x, where the two variables are becoming equal, y is approaching x, we find that we are finding a different limit. And then now therefore we can conclude and say therefore the limit does not exist. So the limit at that point does not exist. Okay, so question 3 now. Let's look at question 3. Okay, so question 3 here. Question 3 says, calculate the partial derivatives of the function f x comma y is equal to x cubed plus sine x y. Okay, so partial derivatives. Okay, so when you are calculating partial derivatives, if you are told to calculate, for example, in this function, if you are told to calculate the partial derivative of this function with respect to x, then if there's any other variable in the function, you treat it as a constant, the way we treat constants. Remember, when we are differentiating constants, a constant, we always get 0. Okay, so this is what we are going to do. And so for partial derivatives, we'll start with the partial derivative of this function x comma y with respect to x. Okay, so we are differentiating this with respect to x. Now it's a partial derivative, so if at all there's any y here, the y will be treated as a constant. So when you differentiate this one here, there's a coefficient of 1 here, you are going to multiply 3 times 1, you have 3x, and then you subtract a 1 from the power, you have squared there, plus here in this function, you will start by differentiating the function itself, sine. So the differential or the derivative of sine is cos. So you're going to have cos here, cosine x y. And then we are now going to differentiate the function or this one, the angle here, xy, the function xy. So when we differentiate this one with respect to x, we are going to have, okay, when we put this in the brackets, we are going to have y here, because x will disappear here when you find the derivative of x. Because it has a power of 1, you're going to have 1 minus 1, which will give you x to the power 0, which is 1. So this partial derivative will be 3x squared plus y cos xy. And so this is our partial derivative with respect to x. And then now we can now calculate the partial derivative of the function with respect to y. So in this case, x will be treated as a constant. So when you look at our initial equation here, our original equation, we have x cubed here. Now when you differentiate a constant, you always get 0. So x cubed here will be treated as a constant because we are differentiating with respect to y. So it will be 0 here. X plus, here the sign will be differentiated because the x and the y are being multiplied here. So we are going to have cos xy, and then after differentiating the sign, we can now differentiate xy now with respect to y. So we are just going to have x. And so this function is going to be x cos xy. And this is our lesson for today. Thank you very much.